Hello everybody! Today is December 11 and we are ready to open a new slot in our coding advent calendar. Today's problem is about binary trees again, and it is marked as hard. The first hard problem we see here in our coding advent calendar. Let's see if it's hard. Here is the problem. Binary tree maximum path sum. A path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them, right? A node can only appear in a sequence at most once. Note that the path does not need to pass through the root. The path sum of the path is the sum of the node's values in the path. Given the root of binary tree, return the maximum path sum of a non-empty path, or of a non-empty path, right? So here is example 1, 2, 3, and the maximum is sum because we can connect them like this, and from left to right we will collect all three items and we will collect 3 as a maximum. Okay, here the maximum sum is 42. It is 15 plus 20 plus 7, and we will not take these ones because this minus 10 will nivellate the advantage of taking this 9. Okay, so how are we going to solve this problem? As usual, when we are working with binary tree, it can be natural to consider binary recursion here. How binary recursion can help us here? So imagine we are considering one concrete node, and we can go down using BFS or DFS for some more precisely to left and right parts of this binary tree and collect some information. What information we can get? We can get the length of the max length of path sum from left side and from right side, and if this path is positive here, we can sum them all together and compare it to the sum we had from another node, and also we will return its maximum path sum to the parent node. So for example, if we consider like this, and for this concrete node, when we are returning operation from its right, we will only consider this one because it produces more value than this one. So when we are considering this edge between root and its right, we will not consider right of this right, we will only consider left of this right. But at that point we will also have value 42 from right side here, because it will appear when we consider this right and its childs. Okay, so the idea, I hope you got the idea. Let's do it like this. I will create a private function which we will call from root, and we will use it for depth first search of a binary tree for DFS. Okay, so this function will return the max pass sum for a given tree node. And also it is not enough, because somewhere we need to collect the max pass sum so far, and we could return tuple as in previous examples, but for today's video I will do something different. I will use it like ref parameter. So what ref parameter does, I can update it in any recursive call, and it will update the parameter, the value for the color stack frame. Okay, as usual, if root equal to null, we need to return something, and we will return 0. Okay, now max left will be a recursive call for the left node. And we will do the same for the right part. Okay, now what? Actually, these node values can be negative, right? And for negative nodes, for negative results, we will consider them as 0, because negative values will not give us any advantage. So in our resulting calculation, they will only they will not bring us any value, so we will make them 0 if they are negative. Okay, and what now? So now we will update our max sum, and our max sum can be calculated from this current point, like this. Max current can be max left, which is already zeroed if it's negative, plus max right, which is already zeroed if it's negative, plus root value, which cannot be zeroed, because if it's zeroed, then we not consider it as a pass sum, so our pass is broken at this point, and our left part and right part are not chaining into the same pass. So we cannot do this. For this reason, we will not zero our current root node if it's negative. But it will be fixed at next level. So even if current node is 0, we can include it in our max current calculation, because it probably will not be taken into our pass sum, but probably it will be. It depends on how big max current will be in the result. And what are we going to do next? We are going to update our max sum, which is our accumulator, and it will contain the maximum value of all max currents all over the tree, all over the all stack frames. So okay, we updated it, and we also need to return something here. And as a return, we need to decide, actually, because we are passing something to the parent of this concrete node, right? We need to decide which path we will choose, which one is better, left one or right one, because we cannot pick both of them, right? So when we pass operation from this node from 20 to -10, we need to pick one, 15 or 7, and depending on which one is better, which one is bigger, and we will take that one. But you should also know that behind this 7 can be something else, and in the result it will be a bigger advantage, it will be a bigger pass sum from right side. So it will be accumulated in max left or max right. And let's do this. Max left, max right. And we will also add a root value here. Okay, so our recursive algorithm is ready, and we need to trigger it somehow. Let's define the initial value of this variable. I will define it as mean value, because in our constraints it is said that values of nodes can be negative, and if they are all negative, then our returning pass sum will be also negative, and we cannot estimate how negative it can be. So we just can define our initial value for max sum as the lowest value we can have for integer, because there cannot be anything below it. And we will need to trigger our recursion algorithm. We will pass our root here and our max sum. Okay, there is a edge case here that means if our tree does not exist, if our root is null, we will return 0 from here, and we will not update our max sum here. But our definition, our description of the problem does not have any qualifications what should we do in this case. And by the way, the number of nodes in a tree can be in a range of 1 at minimum, so it will not be null at all. But we cannot remove this one, because this one is a recursion stopper mechanism in the leaf level of nodes. Let's try and let's call this. Okay, yes, of course, ref. Okay, it works. Let's trigger it, and that's it. It is done. Remember, yesterday I also tried to ask GPT, artificial intelligence, to solve the same problem as I solve. Today I offer you to do this for me and compare my solution with the one generated by neural network. Does the GPT have better solution? Let me know in comments. See you tomorrow.